and welcome to our new video. In this video, we are going to see what is process and each and everything about process. So basically, your laptop or any system have lots of programs. Okay. So when these program is under execution, then this program is known as a process. So basically, you double click on any of the program and it start running. So what is the logic behind each and everything, how the program become process, and how each and everything happen in the laptop or any system? Let's discuss about it. So we all have seen that in any system there are multiple process running simultaneously, but we have only one CPU. So how will this happen? This happen because of a visualization virtualization of CPU. So what will happen there? Your OS create one process, okay, then stop it, then create next process, stop it, create next process, and stop it. So by this way your OS run multiple process in your system, but you think that multiple process in your system, but you think how will this happen if you have only one CPU, only one CPU? And this happen because of the technique known as time sharing. Your OS will give allocated time to each one of these process to do within their time slot, and by this the OS run multiple process simultaneously in your system. So we understand how the program become process, how the multiple system run. Let's now discuss about the architecture of any process. Architecture. Okay. So what will happen? You have a program. Okay. Program basically present in your hard disk or any type of disk. Okay. So how it will become process? First, this program will load in your system. Load the program, and there are lots of static data also loading. Static data are the data which are important to initialize the program, initialize or to run the data, initialize and run the data, static data. Then your OS allocate stack memory basically helps to store written values. Okay. Function parameter and local variable. Next, your OS allocate heap memory basically help to store dynamic data, dynamic variables like like hash table, trees, etc. So after this your OS do tasks related to IO. If your program related anything related to IO, that means accessing any hard disk, accessing any printer, accessing any USB. So this type of tasks is again done. After this, your program go under go to the main memory. Your OS go to the main function of the program, main function of program. And after this your OS give this process to CPU to handle and execute the process. So first what will happen? Disk load the program and static data. Next, stack is allocated for functional parameter written value. Heap is allocated for dynamic variable. The OS do the tasks related to IO. Now the OS go to the main function of program. After this, OS allocate this whole process to the CPU to further execution. Okay. Now this is the way how the architecture of the any program look like. So let us first discuss how the memory allocation happen. Okay, this is the total memory. Let's suppose allocated to the program. So in this part there is a text which contain the compile code. Total code of any program is contained here in this area text. After that there is a data which has the all the static variable which I say is required to initialize any program. Now this contain heap memory is stored dynamically allocated data. Okay. Now in the above path is stored stack which store all the variable, functional parameter, everything. Now if your function have a lot of free space here, why? Because during the program execution it may require lots of heap to store more dynamically allocated data, or it may require more stack memory to store some stack data. So when these two data meet, when heap and stack meet at any place, because it also grew in down one. So at that place, if these two meet, then that is called stack overflow error, because now there will be not more place to grow any one of them. That's why it's called stack overflow error. And if you grow this and there is no extra space to allocate to the heap, if there is no extra memory left to allocate to the heap memory, then it is called memory insufficient error. So I hope you understand now difference between stack overflow. Stack overflow is when these two memories meet each other, then it is called stack overflow error. But when there is no memory left to give to the heap, then it is called memory insufficient error. I hope you understand how the program executed, how the all the memory is given to you. Now let's understand attributes of process. What is attribute? Let's suppose your OS run multiple program. Okay, first is create, stop, then create again some more process, it create more process. So OS has to store the data related to process, because again after time sharing it has to come to execute again this process. So OS has to store the attributes or data related to the process. Attribute to the process. So what are all that data or attribute OS store related to any process? So let us discuss about it. First thing it store is process ID. What is store? Process ID. Each process has its own unique ID. Next is store process state. Process state means in which state the process currently is. Is it in the under execution, or the process get completed, or the process is waiting for IO response. What are there are different states in which state the process currently has. Next is store program counter. Program counter is very important. Let's understand deeply. So basically what will happen, your program has lots of different instructions. Okay, now suppose the program complete up to this instruction. So how will the OS know the address of this instruction? How OS know that after the second step there will be a third step? So in this program controller block में it store the address of the next instruction. So this program counter store the address of next instruction. So when one instruction get complete from this place, the OS know the instruction address of the next place. So OS go there, read the instruction and follow that instruction. So with the help of this, the address of a next instruction can be get. Next is store priority of instruction. There are many process which require priority access. So whether that process is in the priority or not, it can be known by this place. Next is store all the variable data which are required for that process. Next is store list of open device, means this process require which of the device, whether it require printer, desktop, keyboard, all that require IO are stored here. Next is store list of file. Okay, let's suppose this is a program. This program requires two more file. Okay, so it store the list of the name of and address of the file, so that if the process require any file, it directly go read the address and go to that file. So it store the address of a file. I hope with this you understand the attribute of a process. So we discuss about program. When program under execution, it is called process. Your system run one process at a time, but you see that there are multiple processes because of virtualization of CPU. It create stop, create start with the help of time sharing technique. Next we discuss about architecture of a program. It in the disk, it load along with static data, then stack memory, then heap memory, then tasks related to IO, then OS go to main function. OS give control to the CPU to execute further. Now after that, how the memory allocation happen. First text data which contain compiled code, next static data, next heap memory, next stack memory. If stack or heap memory meet any place, that is called stack overflow. If there is no place to give extra memory to heap, then it is called memory insufficient. Next we discuss about different attributes what OS stored related to any process. First process ID, next process state, next program counter, next priority, next static data, next list of open device, next list of open file. I hope after this you will understand fully how the program become process. You just go and double click on any of the process and the process start executing, but behind the scene there are a lot of things OS are doing, and these are all the things the OS is doing. I hope you understand from this video. Let's meet in the next video.